Hi everyone, thanks for joining us. This is a very simple, it's not Hollywood video. Basically we're going to talk about how to convert power cords to use Anderson connectors. And the first part of this thing is going to be method store of madness. Why would you ever want to convert power cords to use Anderson connectors? And then we're going to stop the video, and then we're actually going to show you how you go about doing that. And I think you're going to find it's pretty simple and straightforward. So first of all, this has been the traditional astronomy power plug for way too long. It was never a very good choice, but the first guy to make some sort of electronic device for astronomy, I think he decided to power it from his car, and it was convenient to use a cigarette lighter plug, and unfortunately it's been that way ever since. And our products, people still expect this is what they're going to get, so we still supply our like DO controllers and whatnot with cigarette lighter plugs. But there's lots of good reasons why you would want to change this plug for something way better. And one of the problems with these cigarette lighter plugs is they unplug themselves. I mean, after all, there's a little spring at the front of this thing, and after a while it actually pushes itself out, and then you start swearing and wonder why your mount's not powered anymore. Also, the tip of this thing has a rounded point on it, so the amount of metal that's actually making contact with power is such a small surface area that it really can't handle very many amps of power. And in fact, there's a little glass fuse inside of here, 7 amps, because 7 amps is the most amount of power that you would want to try and draw through a cigarette lighter plug. Anything more than that and this darn thing is going to melt. So the beauty about Anderson is, look at the difference between the two. Alright, not only is it substantially smaller, but it doesn't have a spring on the front. Hi everyone, now we're going to get around to the how-to part. So, and this is going to deal with how to actually convert power cords to use Anderson connectors. So for convenience, we actually sell, we call them a kit on our website, and a kit consists of the black plastic shell, which is what we use for negative, the red plastic shell, which is what we use for positive, and 2 of these little metal contacts. And these contacts are going to go on the wire, and then you're going to insert the contacts into the shell. Now, when you look at our site, we talk about welded and unwelded. So Andersons are a very clever plug. They are what we call genderless. So a plug is a socket, or a socket is a plug. You can actually get them to plug into one another. And in fact, that's how our car panels, that's how they work. It's basically the same shell, it's just how you arrange them. So the way they fasten together, they're a little bit like Lego. Instead of snapping together, you'll see there's a slot, and you just slide them together and then they lock onto one another. Now, the welded sets, some people call it welded, some people call it fused, but basically these little shells, they lock together, and they're hard to come apart when you want them to, but they can come apart. They eventually will separate, and what the welded ones do is they're sonically fused together. If you think of it as being glued, in other words, they're not going to come apart. So that's the difference between them. So one of the reasons that you'd want a couple of each of these things is because this is also a very clever way of making extension cords. So here I have 2 fused, and the dilemma is that in order to be able to connect these together, I need to rotate it so that they'll lock together, except now I've got red going to black and black going to red. So that's why we suggest you always have a few of these unfused ones, and then that way you can orient the plugs the right way, and then they simply will lock together, and then I just slide them together and away I go. And I'm going to actually show you how you're going to use this notion of making extension cords by using, so here's an example of a typical astronomy device that comes with an AC adapter. Now, weird thing about astronomy devices, almost all of them are designed to run from a 12-volt car battery. So these AC adapters, all they're doing is taking AC power and converting it to DC. So your CCD camera, for example, it wants 12 volts. And they always give you focusers, cameras, they always give you one of these AC adapters. Well, that's one more cord to manage, and of course, how do you get this, how do you even get AC? If you're out in the field trying to run from a battery, you're wasting battery power by trying to use those AC DC inverters, and now you've got to get a wire from the ground that goes up to power the equipment. And the whole idea is you bring 12-volt power up to the top of the telescope. Now you've only got one power cord that's going to supply power to this box, and you can eliminate all these other wires, your CCD camera, your motorized focuser, your DO controller, all that stuff. Bring 12-volt power and USB connectivity. We also have a 12-volt hub that can get power from this thing. And then you've only got two wires coming down the mount. But in the meantime, I'm actually going to show you a typical scenario. Let's say you've got a CCD camera, and this is your power cord, and now you got to figure out how to get Anderson connectors on this. So I'm going to show you what I do with my CCD camera power supply. Every 6 months or so, I actually want to take a whole new dark library, and I want to use my refrigerator. I stick the camera in the refrigerator, and I let it go all night long, taking a series to refresh my darks library. But I still want to be able to use the AC adapter when I'm doing this thing where I'm taking darks in the refrigerator. So I'm going to show you how you're going to use the original power cord. You're going to cut this cord, and you're simply going to put Andersons on both sides of it, so you'll still be able to use your AC adapter, and you'll also be able to plug it into your Lynx power panel. And it's pretty simple. All these cords have two wires, and what we care about is which of the wires is positive and which wire is negative. So before I cut the cord, I am of course going to have this box mounted up on my around my telescope, and I'm going to make sure that I'm going to have a cord long enough to actually go to the camera and be able to plug into this. And that's how I'm going to decide where to cut this cord. But I'm just going to go ahead and cut the cord now. Now what I have is I have these two parts here. And now I gotta separate the two wires, and right now I don't know which of these wires is positive and which wire is negative, so we're going to use a multimeter. So what I have out on the table here is basically a collection of the tools that you're going to want to do this. Now Anderson does have a special crimping tool. You just stick the wire in here, you stick this thing in here, and it crimps it. The only problem is these are very expensive. The official Anderson tool costs about $600, and there's some generic ones out there that you can get for about, $100. But if you're only doing a couple of cords, it really doesn't make sense. And this is the only kind of crimp that you can do with this tool. So to me it makes a lot more sense. I believe every astronomer should own a soldering iron and a multimeter, because it's really easy to solder these little contacts onto the end of the wire, and I'm going to actually show you how to do that. So the tools that I have laid out here right now is I have a wire cutter, and I've got two different kinds of wire strippers. This basically removes the insulation off the end of the wire. I actually prefer this type here. These are a couple of bucks on Amazon. These multimeters, what we care about on these multimeters is we want to be able to measure voltage, And we also want to make sure that it has something called a continuity setting. Something like this you can get on Amazon for about $20. And I think every astronomer needs to own this. A soldering iron. This is a pretty decent one. It probably costs $120. But there's on Amazon, eBay, whatever, there's a number of soldering irons. You're not going to do this as a professional. You just want a soldering iron that gives you the ability to set a temperature on it. And you want this style. You don't want the old gun style. They don't get hot enough and they're really tough to work with. But usually you buy one of these soldering irons, you can get them for as little as $40. And you just want one where you can set the temperature. I set the temperature to anywhere between 700 to 750 degrees. And the other tool that you want, you kind of need 3 hands to do this thing. And of course, they actually call this thing the third hand. You get these on eBay, Amazon for about $6. And it's just going to let you clamp the wire in there while you're soldering the contact onto the end of it. So anyway, I've cut my wire and now I've separated them. I'm going to give myself a little bit of slack here, and I'm going to use my stripper tool. And right now I'm not even worried about which wire is negative and which wire is positive, but I've just bared enough wire so that and then this wire is going to get inserted inside of this contact. So you just want the bare wire to go all the way in. And then I'm going to take my little third hands here and I'm just going to set it up. And I'm going to slide this little sucker on the end of it. And I have a spool of wire here. A spool of solder. Basically you want electronic solder, and it's going to have a rosin core, and sometimes you can just buy a little tiny spool of it for a couple of bucks. So you don't want plumbing solder, you do want electronic solder. And the whole idea behind soldering is, and it's also true if you're soldering copper plumbing pipe, all the parts that you're trying to get to solder together need to reach a temperature that will melt solder. If one part is hot enough but the other isn't, then the solder isn't going to stick. And a dry tip soldering iron doesn't transfer heat as well as if all I'm going to do is I'm just going to touch the solder wire to the tip of my iron. And what this is going to do is, because I have liquid solder on the end of it, it's going to actually heat the parts up really quick. And that's actually what we want. We want to heat it up as quickly as possible, and a dab of liquid solder will do that. Now you'll see, you probably can't see it in the video, but there's a little hole. You see a little wire sticking out here. There's actually a hole at the top of this thing. And all we want to do is we want to get some solder just to go down into that hole. And one of the cool things about solder is that it has a kind of wicking action. So all I'm going to do is I'm just going to touch my iron here, and I'm actually going to touch the solder to the tip of the iron. And I just want to get enough solder to go in there so that it kind of fills the hole. And that's basically it. And it heated up both the contact and the wire hot enough so that solder would stick to it. And now we can be careful, this thing is still going to be hot for a while, but we can actually just grip this thing, give it the tug test, and we have a nice, very simple solder connection. Now I'm going to go and I'm going to put the other one on, and then we're going to show you how to tell which wire is positive and which wire is negative. So bear with me real quick while I take care of the other contact. I'm just going to turn this around so that I can see the little hole sticking up. And I'm going to use my little third hand here. I got my spool of wire. I'm going to take my soldering iron. I'm going to turn this thing around so that I can see it. Melt some solder on here. I'm going to touch it to the top of this thing, and I'm going to touch the solder wick, and I'm just going to fill it with enough solder that it goes down into the hole. And then I'm going to do a little tug test and just make sure that I got a good contact here. Oh, it's still, I tugged too soon because it was still melted. So I'm just going to give it another touch again. And then I'm going to wait a little bit longer for it to cool below the melting point. Okay. So that should do it. So I'm going to blow on it, help it to cool off. And then I'm going to give my tug test just to make sure that it actually fused. Yep, we're good to go. Now, I have to figure out which shell am I going to stick these contacts in. So the red shell is for the positive, the black shell is for the negative. And this is where I'm going to use my trusty multimeter. And one of the cool things about any what we call circular type connectors, barrel connectors, cigarette lighter, it's always center positive. So in the barrel connector, it's actually what you're plugging into. There's a pin, and this thing is going to insert on top of the pin. The center of this thing is the positive, and the metal on the outside that you see is actually the ground or the negative. And all we need to do is use our multimeter, and we're going to set it to continuity. You probably aren't going to be able to see this in the video, but there's a couple of different things you can do with a multimeter. One is measure voltage, the other one is measure resistance, stuff like that. But what we care about right now is this little continuity. And all that's going to do is it's going to tell me when a circuit is completed. So here's my two probes, and if I touch the two probes together, you can see that the multimeter is reacting. And that's how I'm going to use that to find out which one of these contacts meets up. You'll see I'm putting the probe in the center and sticking it in there. And now all I have to do is to figure out which one of these things is positive. And I'm going to look at my multimeter now. I'm going to touch the other probe. No, it did not react. So that must be the ground one. And now I'm going to touch it to this one. And you see the multimeter is now reacting. And therefore I know that this is the positive. And this means I'm going to stick it into the red shell. Now, if you won't be able to see this in the video, but when you look on the front, the face of this thing, you'll actually see inside there's a piece of metal, and the contact is curved. And when you slip it in there and you push the contact forward, this little curved end is actually going to grab hold of the piece of metal here, and that's actually what's going to lock it in place and keep it from pulling out. So in order to get it to go in there, it's a sort of up and over kind of action. Now we have a pretty fine wire here, so we're probably going to need to, it's not going to be stiff enough to let us push on the wire to get it to snap into place. So we're just going to take like a jeweler's screwdriver here, and we're just going to grab hold of the back of the contact, and we're just going to push on it, and you'll actually hear it click in place, and that's it. Now our contact is in there, and all we have to do is now put the other one in. So again, the curved end, I just want it to go over top of the piece of metal, so I'm just going to insert it in here. I'm going to push at the back of it with a little jeweler's screwdriver, and I heard it click in place. And before we actually plug anything in, I'm going to do a double check using my multimeter. I'm going to go and I'm going to stick one probe into the center, which is the positive, and I'm going to touch it to the red metal contact, and sure enough, yes, it is reacting. Now we can plug into our power panel and we're all set to go. Now we talked about how I still want to be able to use the AC adapter so I can do my little trick of taking darks in my refrigerator. So we're going to do the same thing to this end of the cord. We're going to do exactly the same thing, and in fact I'm going to get Joe to pause the video because you don't need to watch me. Well, I don't know, keep it rolling. let's just do the whole exercise. This time when I go to check to see which wire is positive, I'm actually going to I'm going to plug this in, and I'm going to use the voltage setting on the multimeter, and it's going to tell me if I see 12 volts, it means that I've got I've identified the positive. It shows me a minus, it means I got to reverse them. So anyway, we'll get to that in a second. So let me just solder these contacts on real quick. That's one. Oh, it was still molten, so it came off. I gotta be more patient. Here I am trying to make this video really quick, and I'm not being patient. So let me just touch this again. Okay, while we're waiting for that thing to cool, we're going to take our set of unwelded Anderson contacts, and we are going to find out how we need to orient the plug. Of course, we want red to go to red, so I need to turn this way. We want black to go to black, so that means I gotta turn it this way. And now all we have to do is to slide them together. Excuse me. So this is now taking those unfused ones, and this is going to go on the end of the AC adapter, and now we'll be able to still use the AC adapter as soon as we finish soldering this other wire. So yeah, it's gone there now. Let me just do the other contact real quick. Some solder on the tip. Let it wick inside there, and then I'm going to be patient and let it cool down. And by the way, you'll see I've got a piece of electrical tape wrapped around the jaws of these things, because if, of course, the wire is going to get hot, and if it gets too hot, the vinyl insulation is going to start to melt. And these clamps on these third hands things have jaws that are actually serrated and quite sharp. It will actually bite through the wire, so it's a good idea just to wrap some electrical tape so that you don't end up piercing your wire when it starts to get warm. And that's one of the reasons why you want to get the contact to heat up as quick as possible before the heat has a chance to travel down the wire. We're going to do a little tug test. Yeah, we're good there. Now we have to find out which of these contacts is the positive and which is the negative. So we're going to pause the video because I forgot to get an extension cord to plug this thing in. So go ahead and pause. Okay, we're back. Sorry, we had a little drain, our battery drain. So we're going to just finish this last couple of seconds here. We were talking about how to take a power AC adapter that came with focusers and cameras, and how to convert it to Anderson, and also how you could still use the AC adapter if you wanted to, simply by putting on another set of Andersons and in a sense making an extension cord out of it. So we've already figured out which was the positive and negative on this wire, and now we have to do the same again. Now, some wires you'll see markings. Sometimes there's printing on it, sometimes there's little texture to it. but you can't really depend on the markings on a wire to tell which wire is positive and which is negative. And if you had two identical units, you also cannot be assured that they were wired the same way based on how the wire is marked. So you're always going to want to use a multimeter to know for sure which is which. So we have our multimeter, and now we're turning it to the voltage setting. And I don't know if you can see it here, but we have it set on the 20 volt DC setting. And now our probes, the way our probes are set up, is the red probe represents positive, the black probe represents negative. And what we're going to do to find out which is which is I'm actually going to plug in the AC adapter to AC power, and I'm simply going to measure the voltage that's coming out of the contacts, and the meter is going to tell me whether I have polarity right or reversed. So I'm just going to make sure before I plug this thing that these two metal contacts aren't going to touch one another, because that would create a short circuit. So now we have it plugged in, and now I'm going to take the probes, and of course I don't know which one is positive and negative, and this is what the multimeter is going to tell me. So I'm simply going to take the probe and I'm going to touch to one contact, and I'm going to take the other probe and I'm going to touch it to the other contact, and I'm going to read the voltage, and the voltage tells me it's 12.41 volts. Now, the way these multimeters work is if you had reversed it, and I'm going to actually reverse it on purpose, and I'm going to reverse the probes, and now what the display is going to display is it's going to give me a negative number, which means I now have a reverse polarity. So in other words, if I go back the other way again, and it goes from showing a negative number to a non-negative, that does tell me that this contact here is actually the positive. And I'm going to unplug the power supply, and I still have my fingers knowing that this is the positive contact, and I'm going to insert it into the little shell that we put together a little while ago, and we're just going to insert it in there. And I'm going to use my jeweler's screwdriver just to help push it in there. I heard the click. I'm going to put my negative in there. So now we have everything together. These two cords will now mate. So I have the two pieces of my original power supply, and I can now connect the two together, and just to double check, just to make sure that we didn't somehow reverse polarity again, we're going to plug the AC adapter back in. This time we're going to take our voltage meter and we're going to stick the red probe down the middle, because that represents the positive, and we're going to touch the black probe to the outside shell, and we're going to check our voltage reader, and it's not showing a minus, so that means that we got it right. Now the way that we're using these adapting power cords is pretty well the same thing. A little while ago we talked about how our Digifire controllers, the power cords do come with a cigarette lighter plug, but that we also give you a special kind of terminal plug, and you can use your own power wire, or you can take the cord that you got, cut off the cigarette lighter plug, and follow the same procedure. The user guide for the Digifire controller will actually tell you which of these terminals is positive and negative, and you're just going to repeat the same exercise. By the way, these little terminal block connectors, they're a pretty common way of connecting wires. You can simply take a wire, strip off the insulation, and you can actually stick the bare wire into the end of it, and then screwing it down just clamps down on the wire. But any kind of wire that you use, if you bend it back and forth a bunch of times, it's going to start breaking the individual strands of the wire. So it's always a good idea to use these ferrule connectors, and it's a very simple thing, and it's actually a very inexpensive. This tool you can get on Amazon for $15–20, And this is a special crimping tool for using these ferrule connectors. And all you have to do is you just strip the end of the wire, you stick it into the little barrel here, and you just make it so that the bare wire comes to the front. You stick it in the crimping tool here, you squeeze it, and it's going to give you this kind of squared off thing, and it's going to grip the wire. And now you can insert it into the little terminal block, and it's a lot less likely that bending the wire is going to snap the wire off. And you'll actually see if you buy one of our Digifier controllers, the cord you get from us is actually going to use these. Anyway, and that's it. And I hope you found it a fairly simple process, and don't be nervous, give it a try, and you'll really like the results that you get from getting rid of cigarette lighter plugs. Thanks for watching.